It might just be the most universally known fact in chemistry, the chemical formula for water, H2O. A model of H2O doesn't look like much. Two small atoms of hydrogen, the H2 part of H2O, attached to one bigger atom of oxygen, the O part of H2O. Water, H2O, is the only natural substance on Earth found in all three common states of matter: liquid, solid, and gas or vapor. It's also one of the only common substances that is less dense in solid form than in liquid form. And water can dissolve more substances than any other liquid.
Pure water is essentially colorless, odorless, and tasteless. Water has a neutral pH, which means it is neither acidic nor basic. Water has been called the universal solvent because it can dissolve many substances. Wherever water goes, either through the atmosphere, the earth, or through our bodies, it takes along valuable chemicals, minerals, and nutrients. This is one reason why water accounts for about 70% of the weight of a cell, which is the building block of life. Water has high specific heat, which means it absorbs a lot of heat before it changes temperature. This is why water makes a great coolant. This is also why oceans, lakes, and water vapor in the atmosphere help to regulate the Earth's temperature. Water molecules are sticky. They attract to each other, which is why water tends to float together, fall as raindrops, and bead up on the surface of a leaf. This property is the result of cohesion. Surface tension is a result of cohesion and is the measure of how difficult it is to break the surface of a liquid. We can observe the high surface tension of water by watching this mosquito step onto its surface, or this insect as it struggles to free itself from a droplet. Surface tension is also what causes a water droplet to take a spherical shape. Water is the most cohesive of all non-metallic liquids. Adhesion is similar to cohesion, but refers to two different surfaces or molecules with an attraction to one another. This is why the droplet sticks to this leaf. Along with cohesion, adhesion is responsible for a phenomenon called capillary action. Capillary action is the force that pulls water upward against gravity through a narrow tube. This is an essential property for plants, which rely on capillary action to pull water from their roots up to their leaves.
Let's focus on H2O in liquid form. What gives water its remarkable qualities and abilities? It's all in the molecule's content and structure. Not just what each H2O molecule is made of, but how the atoms are positioned, in what configuration and shape, and how they are bound together. In water, just so you'll know for later, the H's and O's are held together by covalent bonds, by sharing electrons. H2O is a polar molecule, and like a magnet, H2O has one positive end and one negative end. This might just be the second most universally known bit of chemistry. Opposites attract. The positive hydrogen side of every H2O molecule is going to attract and be attracted to the negative oxygen sides of other nearby H2O molecules in all directions. More and more of them pull closer and closer together, and molecules that stay close to each other are called cohesive, and water is highly cohesive. A pentillion, even hextillion of chaotically moving, tightly packed H2O molecules cohere to make a single raindrop. As good as water molecules are at all this cohering and convening, they also form bonds with surfaces and molecules unlike themselves, a force called adhesion, as in adhesive. Pour the water out of a glass, and the inside of the glass is still wet. Some H2O molecules stick or adhere to the silica molecules in the glass. Being cohesive and adhesive is what makes water a near universal solvent. How? Take salt or sodium chloride, sodium ions, abbreviated as Na+, and chloride ions, abbreviated as Cl-, in a crystal. As soon as a salt crystal hits the water, It's rushed by a molecular mob of H2O molecules that break it apart, separate the sodium and chloride ions, kind of a chemical divide and conquer. Because sodium ions have a positive charge, each one is swarmed by H2O molecules flying at it with their negatively charged oxygen sides, completely surrounding the sodium ion, isolating it, carrying it off in a turbulent sea of H2O molecules. The same thing happens in reverse to the chloride ions, which have a negative charge. Each of those is surrounded and isolated by H2O molecules leading with their positively charged hydrogen sides. Each salt crystal is broken into tiny pieces, dissolved by and into the water.
In elementary school, we learned about the water cycle.
The process by which water circulates from the ocean to the atmosphere to the land and then back to the ocean. Water on the ocean surface evaporates, can travel as clouds or vapor over land, fall as rain or snow, and then work its way back to the ocean through rivers, surface runoff, or as icebergs. In other words, the ocean plays a major role in the water cycle. In fact, 86% of all global evaporation and 78% of global precipitation occurs over the ocean. As the water cycle changes, so does salinity. Ocean salinity is affected by the water cycle. As salt water evaporates or freezes, the salt is left behind and salinity increases. But precipitation and runoff dilute salt water, decreasing salinity. Now, while these changes in salinity may seem insignificant compared to the size of the ocean, they make a huge difference in how water circulates.
Where water from the ocean evaporates to form clouds that move over land and drop fresh water as rain or snow. This precipitation soaks into the land and is stored underground, or it flows into rivers that ultimately return to the ocean. Rivers are the circulatory system of our planet that provide vital habitat to fish and aquatic life, and move nutrients and sand downstream to replenish wetlands and beaches at the river's mouth.
Looking at our Earth from space, with its vast and deep ocean, it appears as though there is an abundance of water for our use. However, only a small portion of Earth's water is accessible for our needs. How much fresh water exists and where it is stored affects us all. Nearly 2/3 of this fresh water is stored in the polar ice caps, snowpacks, and glaciers, making it inaccessible for long periods of time. The water cycle is dynamic. It describes the continuous movement of water on, above, and below the surface of the Earth, and the transitions from one state to another. Sea surface temperature, surface winds, and air temperature influence the rate of evaporation at the ocean surface. In the tropics, warm ocean surface temperatures support high rates of evaporation. Wind also increases evaporation. When the air's temperature is warmer, it can hold more water. While the atmosphere does not store a large quantity of water compared to the ocean, rivers, and lakes, it can transport water quickly from one place to another. Low-lying regions of the atmosphere with high moisture and strong winds can form atmospheric rivers to transport water horizontally. Clouds are formed as water vapor cools and condenses into droplets and ice crystals. Clouds and water vapor act as insulators in the atmosphere. Clouds help shield the Earth from the sun and trap heat from below. When cloud particles grow large enough, they may fall out as rain or snow. Under the right conditions, areas of precipitation can grow into large storms. As storms grow, they transfer heat vertically into the upper atmosphere. The migration of storms helps to distribute heat between the equator and poles, shaping wind patterns globally. How storms grow and intensify depends on atmospheric moisture, surface temperatures, and wind patterns. Precipitation is concentrated in some parts of the world and scarce in others. It can vary substantially from season to season and from year to year. Water that falls on the land surface as precipitation is stored within snowpacks, lakes, reservoirs, soils, and underground aquifers. Water availability varies from place to place and over time. The availability of water affects the type and abundance of vegetation, the primary source of food for animals and people. Extreme water cycle variability, unusually dry or wet conditions, impacts humans worldwide. Each year, hazards such as floods exact a costly economic and human toll. Most of the water that falls onto land remains stored there for weeks or more. Snowfall is stored as snowpack or ice. Meltwater and rainfall are stored in lakes and soils. Some of the water is absorbed by plant roots or drains into the water table. Eventually, the water will evaporate to the atmosphere or return to the ocean in streams and rivers, providing a source of nutrient-rich water that supports ocean life.
Water covers around 70% of our planet, but almost all of the water on Earth is salt water from the sea. It's fresh water that we need to drink, to grow our food, and sustain our natural environment and our health and well-being. Clean, fresh water is one of the most precious substances on Earth, because without it, there can be no life.